All right, we're back. We're on page 4 of notes 1 of Calc D. So multivariable stuff. We're doing some vector stuff, some 3D stuff. This video is going to be all about what are called components and projections. So components are scalars. Projections are actual vectors. The component is the directed magnitude of the projection. So I'm just saying a lot of things. The notation kind of looks like this. So it's the component, COMP, of PQ along PR. So PQ is going to be kind of projected onto PR. PR is like the base along which you're projecting. It's kind of like an axis, right? Like that's the direction. That's our positive direction. And then PQ is going to be projected onto it. So let's see what that means here. So we have PQ, and PQ is going to be projected onto PR. So what I do is I kind of like picture as if there's, let me see if I have like a yellow, right? So it's like there's like a light source up here, and it's going to project, it's going to cast a shadow. And what we're going to do, we're going to find the component. The component is the shadow of PQ. So here's PQ. It's the shadow of PQ along PR. PR is like the ground, right? That's where the shadow is going to fall. So that's what we're going to do. We're going to try to find that. So I think of the component as literally the shadow of PQ, and it could be directed, right? So it might be, here you can see it's going to be on PR. If PR had been facing this way, then the shadow wouldn't have been on it, but it would have been on like the negative part of it. So you would get a negative in that context. So let's see if we can actually work it out. So the way we do that is we use two things. So this angle is going to be essential. And the first thing we'll do is focus in on, well, I don't know. Yeah, I don't know how I meant to do this, but this is what I'm going to do. First, I'm going to focus in on the two vectors. So I'm going to focus in on PR and PQ, all right, as vectors. So I know that the angle between them, cosine of theta, is the dot product. So PQ dot PR over the product of the magnitude. So PQ, PR, right? So that I definitely know. Now I also know, so that's from vectors. So should I do this? PQ, PQ, and then PR, PR. All right, I also know from the right triangle, so the right triangle here, and then we have this. From that right triangle, I know that the magnitude, well, cosine of theta is going to be PS. So what color should I use for that? Run low on colors here. So PS, the length of PS, or PS, is actually the component. So it's PS, that's adjacent, over the hypotenuse. But the hypotenuse is the magnitude of PQ. It's not PQ itself. So the magnitude of PQ. PS is not a vector. I mean, it could be a vector, but I'm not thinking of it as a vector. I'm just thinking of it as a line segment. So this, from here, if I multiply across the PQ, it's going to cancel. And so I get that PS, which is essentially the shadow, right? It's the shadow. It's the length. The length of this is the length of the shadow of PQ on the ground, which is PR. So it's the component, we call it, of PQ along PR, but it's just the shadow. So PS is going to be PQ dot PR over the magnitude of PR. Now, so this is the component of PQ along PR is PQ dot PR over the magnitude of PR. So now you might be looking at this and thinking to yourself, isn't PR over the magnitude of PR just a unit vector in the direction of PR? In fact, it is. So another way of thinking about this is to think of it as this unit vector dotted with PQ. So PQ is the one we want to find the shadow of. So it's the dot product of the vector we want the component of, or the shadow of, with the unit vector in the direction of kind of the axis or the ground. So that's how I really think about it. So so the component of A along B is going to be component of A along B. So the base is B, right? It's the ground. That's where we're casting our shadow. It's going to be the dot product over the magnitude of the ground, or it's the vector we're finding the shadow of, the projection, the component of, dot product with a unit vector in the direction of the ground. So the component is going to be a scalar because it's a dot product, right? Dot products are scalars. So the component is a scalar, and it could be positive if the angle between these is acute, right? You're definitely going to get a positive because the dot product would be positive. It could be negative if the angle is obtuse. If the angle is obtuse, then the component will be over here, right? It's not in the direction of that vector, it's in the opposite direction. But that's not really a problem. That's like, it reminds me of like when you find not exactly the height, because you're not really finding the height, but it's when you find the height of an obtuse triangle, right? So if you have an obtuse triangle, so this is your triangle, but when you find the height, it's out here, right? This, instead of the height, we're interested in this part is going to be your component. And it would be negative in that case to indicate that it's not going in the same direction as PR or as the base. So the component can definitely be, it's the signed magnitude of a vector. I think that's a great way of thinking of it. It's definitely a scalar. It's a dot product of the vector that you're interested in with a unit vector in the direction of that base vector. And then the projection is actually the vector. So it's the actual vector PS is the projection. So we know what to do with that. You just take the unit vector, so you turn PR into a unit vector, and then you multiply it by the component. You give it the magnitude that you want. It'll be a directed magnitude, so if it'll go in the direction it should, based on the angle. Is it acute? Is it obtuse? But it's just the component that we calculated times that unit vector of the base, so in the direction that you want. So the projection is definitely a vector. I'm not really doing any problems in this video. I'm just explaining the concepts, but component's a big deal. Comes up all over the place. Projection, like I've looked at some textbooks that don't even mention projections, because sometimes it's really that the absolute value of the component and the component in general just show up like all over the place in things that we do. The projection, I mean, I guess everywhere there's a component, there's a projection. And maybe sometimes it's nice to think of the actual vector, which would be the projection. I don't know. But anyway, this is the big takeaway. Component is A dot B over the magnitude of B, where B is the base. So it's along the base. A dot B over the magnitude of B, or A dot unit vector in the direction of B, in the direction of the base, in the direction you're going, right? So that's your component. Projection, just multiply it by the unit vector again to get the vector. All right, so I'm going to stop this here. The next video, we're doing problems. So if this was a little too like, then in the next one, it's all problems. So I will see you in the next video.